Hey guys, this is Mainak Choudhury, your civil bro, and today we are back with another video on Tekla Structural Designer. So many people were commenting to make a video on Tekla Structural Designer. So if you want regular videos, make comment below. Then I'll make sure I'll come up with some interesting content on this Tekla Structural Designer or some regular video links as well. Okay, for you guys. So make sure you like the video. Really helps the YouTube algorithm. So we'll make composite building today, and we see that there is increase in the use of composite buildings, and that is maybe columns are of RCC, beams are of steel like this. The most commonly I am seeing here in the place where I live here. So let's see how to design these composite buildings, and obviously the connections won't be design connections, you have to design manually or by some other process. We'll discuss that later. So let's see how to design composite buildings in the Tekla Structural Designer. So I will design a building. So first of all, make sure you just click on the new, and after you click on new, the new file, you will open it. And before you go, make sure you make the changes to your country's code as per your country and which you are currently. You can see here is only India. I'm currently using this, but you can import any country which you want, whichever code you're using. So US, UK, British, anything you can just change it. And also in this is the settings, and also in this model settings also you can just change the codes. So you can change to Euro code, UK code, whichever code is preferred in the area of the building which is going to be constructed. So these are the Indian codes. IS 875 part 1 to part 5 are the Indian codes for the loadings, and this A1893 is for the earthquake loads, and there is IS 873 part 3 is for the wind load. So these are the things here, and you can see these are the latest updated codes here. Earlier code was 2016, so we have the updated codes here available for this, and latest seismic code is 2016. So we have the updated code set since it's the updated version of the Tekla structure. Then we have the updated codes, so no problem in case of the updated codes. But there are some things which doesn't work in the Indian code in terms of the foundation. There is also always a warning. If you watch my videos regularly, you know that. And there is also a glitch in the beam design on the top and the bottom reinforcement in case of compression tension. So there is a glitch, but other than that, it's these are some glitches which are occurring in the Indian code, or other than that, we can use the software. So after you just done this settings, and after these settings, you can just go and organize your building. So first of all, you need to just make a grid line here, or you can import from CAD also. But now we'll just make grid line, and before that or after that, you can make the construction levels. So we make the construction levels, insert below. So this will be my foundation level here, and foundation level will keep this as plinth level. Foundation level, let's go 1.9 meter. Okay, below the plinth level, this is the plinth level. We'll take this as a plinth. Okay, insert above, and this level spacing, let's go 3.2 meter. This is standard floor to floor height. Here this will be we'll take this as SSL structural slab level, and we'll insert another floor above it and the same spacing. So basically, this is a good little G+1 building, and floors I want to give of RCC, and so I want to give 150 slab for this RCC floors, and then we'll just click on OK here. So you can see if you want to access your levels, this is a 3D view, this is the base view. So if you want to go to structures and go to click on open the levels, these are the levels: foundation level, plinth level, ground floor slab, and first floor slab. So basically we'll go to the plinth level and make the grids here. So there are similar to the other software making grids. If you see, you can go to rectangular wizard and make the grids here, or you can insert the coordinates as well, or you can import. So there are various methods. I'm just showing you a basic thing. Just go and first of them, don't you can click next on X direction. Number of counts you want, 3 counts maybe, and length of maybe 5 meters, and then let's go with 4 and count of 4 meters, and click on next, and finish. So these are my grid lines, and if you I told you we want to go for your RCC columns. So there we have column here, and you can just select any feature and then go ahead. So we'll go here with FE FE 550. This is the one which is being used here currently. So FE 550 we are going to use, and here concrete grade M25 is being used. Okay, let's keep M20, no problem. Nominal cover 40 mm, and also here you can, if you want to place columns at every intersection, you can do that, or else you can just select a space point specifically. 400 to 400 is the column size. You can change that also. You can go to structure 3D and see these are the columns for the G+1 building. Now let's place some beams at the plinth level. So for placing some beams, we go. We want steel beams. Okay. So for placing the steel beams, we go here beam. Now you get to choose your sections here. First of all, the steel grade, which is commonly used as far as here, FE 490 is being used. Also higher grades are also used. And this auto design is on, meaning if you provide a steel section which fails, it will automatically go to the next higher part and make it fast. So these are the sections here. ISMB are pretty much common sections which have been used in here. We'll go with MB 400, okay, for the plinth beam, and let's see. So same angle will join all the points which has, because the gaps are 4 meter and 5 meter, pretty large gaps. So we'll join all the main beams. Also, this provides stability to the structure. See in the structure 3D, and you can zoom in and zoom out and rotate with the help of right click of your mouse. You can see these are the your plane beams, and we'll go to the next floor and provide the beams as well. But in this floor, we'll go for a higher higher size. Obviously, FE 490 will be the grade. The grade will be the same here, but the ISMB, this section will go for the higher section. We'll go for 550 here. Groove beam, much more loading here. So FE 550 this, and yeah, here you can go for steel decks or RCC slab. We'll go for the RCC slabs here. So slabs on beams, and we're going for the RCC slab in the steel beams. So already slab is, all of them are two-way slabs, so no problem in that. Notice you can just drag and put the slab as well, so there is no problem in providing the slab as well. Here there can be a staircase in outside, maybe steel staircase, or else in the staircase portion you can just delete the slab and provide the staircase in that particular portion. So I'm not using the staircase here, so that's why it is not necessary. Now we can copy this to the next level as well, construction levels, and here make them one, and just go here, and then construction levels, make them back to unique. This step is very important and many people forget. Now in StatPro, if you are working in also in ETABS, you make this supports as you know what I'm talking. It's fixed. So you can see all are fixed. Whatever there is free, make them as fixed. So this generally denotes the very will have confusion. This generally denotes the monolithic connection between the column and the footings. So since we are not doing footings here, we are just considering the monolithic connection with the between the column and the footings. And when we'll just take the load from here, we'll take the load from this portion. It will have a this forces and movements from this bottom of this supports. So make sure you make this as fixed support. This is necessary technical point of view. Practically, it might not be that much different in the design of the superstructure. That is the portion above which you're designing now, but it's always advisable to make them as fixed. Okay. So once you do this, and this is your model, as modeling is pretty much complete. We have the beams, we have the columns, we have the slabs. All the properties have been defined. Now only about the loading. So many people have complained that the loading, when you provide the wall load here, like in StatPro, we cannot provide all at once. So that's the thing. That's a disadvantage, but we'll take it. Go to loads, and we have this option of your dead load, and we have the full UDL option. We'll go load of 7 kilonewton per meter, and like you can see, you can drag it. We have to click each and every member here, and then assign the load. So it can take some time. Both in Stat and ETABS, see this step can be done with a single click if you want to apply loads to all the beams. So that's a thing. And here there will be the plinth be on a plinth level, there will be filling, so we'll not provide in live load or etc. or the here in the 3D also you can see this. dead load here. And in the next floor, we'll go here to, we'll go here to home, and we'll go to the structure 1, and we'll go to the load here. And here we said just to go dead load. Again, full UDL of 7 kilonewton per meter. I made many videos on how to calculate this. You can see them, or else if you want again, just comment below. I'll make a video for you. No problem. So this codal provisions and how to know which load will be applied where. This is very important. And then in the dead load also there is another load in which will go a level load. So this is the floor finish load of tiles, marble, whatever. As per IS, 875 part 1, the maximum which I found is 0.5 to 0.7. So we'll just go 0.5. It pretty much covers every flooring material which are being used here. And then after this is the dead load which is applied. And then we'll go to the topmost floor maybe just to provide and finish the dead load here. In the topmost floor, there can be parapet walls here. So only the parapet wall load we will provide, and this will be full UDL parapet wall load. Let's take as 3, and along the perimeter we'll just provide here, right? And you can select this option as well. I'll just Control Z and perimeter, and you can see perimeter it selects all the slabs. So that's the problem. So you have to just go and select all the boundary. So that's it. We don't need any floor finish load here. You could just check in 3D. This is the good old dead load applied. The self weight they calculate automatically. You don't have to apply it. So the parapet wall load and the load of the walls or the beams. So these are the loads which have been applied, and then we have the floor finish load as well, and then we go for the live load. So first floor, and we go live or the imposed, and this is for IS 875 part 2. We can apply the live load, full level load. Here we'll apply a level load of here we'll go let's say 2, and just click here, and again this floor also you can apply the live load here, but this floor will not be used for any special purposes, so you can apply or cannot you can ignore that as well. Okay, just go to and click on it. So here you can just change to imposed. I can see this imposed loads here acting. So this is pretty much it. And obviously nowadays seismic awareness, you did want to design all the buildings for your earthquake. So minimum, if you don't take both loads also, it's okay. In some cases, you just need to take the seismic load. So go here, loading. And in the loading, we have this, loading, we have, this wind load. We don't want to apply wind load now. We go seismic load, seismic has hazard, wizard, sorry. And then next, and then you have this highest level. This all take automatically ignore seismic below the whatever you've taken as the your plinth level, and zone you define. I live in zone 5. So importance factor, this is the revised importance factor 1.2 is for mainly for apartments and other 1.5 is for special buildings, especially the public buildings. Okay, so this is the case. I like to use model response factor analysis. You can use any of them. Okay, so next, and then you have this moment frame system, and obviously this is SMRF, and SMRF gives ductile detailing as well. So if you want to design ductile, go with SMRF. So you can see this seismic drift story drift checks allowable to story drift check is 0.004, which is as per the IS code. So if you click on override, we can override, but this is the story allowable story drift factor. So just click on finish, and then you have this operating next, and you have this limit state. LS means limit state. We have two loads as per the IS code, limit state and working stress. Working stress is the old one, more conservative and more uneconomical design, but safer. And limit state is the one which you're currently using. So go for the limit state combinations. No need to change anything here. And obviously then you need to go light load combination 875 part 5. The reason I keep mentioning the codes is whenever you go to an interview, just to a new organization, they ask about these codes. Okay, so telling the knowing the technical things while doing that, that is usually helps. So just click on OK, and then we go design, and I go simply design all static, design all concrete and RCC at once. So no need to click all the other things. So it takes some time depending on the structure here, and you can see with steel there is a feature of auto design, so it's really helpful. But you need to use it properly, otherwise we end up with very ununiform section. So for the beams, you can see MB 300 was enough, and for the roof beams, it's coming MB 225. So this is strange. Generally, MB 200 also in some places. So what you need to do is you need to manually provide a uniform type here. Okay. So if you decide like 250, so I've made every one beam of 250. Okay. So that's software is not that smart. So you have to decide on that, or you can turn off auto design, and then I can check. So that will be also thing for introducing a same kind of beam, because mainly in steel buildings we want same kind of beams, right? Otherwise it will be too complicated the design. So this 300, I want every beam of 300. Okay, so economy as well as the convenience we have to look out. And the columns, G+1 columns, building columns, you can see, right, you can check from the static. I think 4 bars of 16, okay, 8 bars of 16, pretty much standard for a G+1 building. Okay, so no problems in that. And the design is of this building is now completed. And if you want to go for the foundation as well, so let's go to foundation, pad base column. I see in India many people when making the houses, they refuse to go for the soil test. They invest a lot of people amount in the building. So, but what is that? What you should know that if you go for the soil test, many times you will save good amount of money, right? Okay, this apart. So here you have this soil characteristics which you insert from soil test report. Here, allowable bearing capacity here is around 110 in most parts here. So this is the case, and we'll just go here, isolated footings, and we'll go here, design pad basis. So we can see this is the glitch which is in that I was talking about. Everything will come as warning, but the warning is not, if you design the same thing by Eurocode, they will not get any warning, because the warning is about development length, which is already provided. Okay. So that is the glitch which needs to be removed. Hopefully they'll remove in some version, but not today. Okay. So you can see the design is pretty much economical, 117 depth 300 to 2050. So this is pretty much economical footing design. Okay, and you get the drawings as well, you know drawings and reports as well in this particular software. So I'll just show you some drawings. Maybe column schedule you get CR01. Okay, just click on OK. I don't want to save this pretty much. So if you get this drawings here for the columns, and then you have this uh, let's go to a particular level here. Let's go to foundation level. And you go to foundation level, the options, more options come. So you got a foundation layout. You can save the file in specific location if you just change that. So you got a foundation layout and the drawings. So it's pretty much convenient. And then you have this general arrangement drawing. And in general arrangement drawing, if you are using various types of columns, then you will find the column number of well. So this all columns CRC D1 all are same here, but in larger drawings you'll find different types of columns here. Same with this thing, you can do the general arrangement drawing for the plane beam. You have this numbers here, MB300, MB300, MB300. So you have all these numbers here, and sections you can find from this. And there is your report. You need to generate the report, whatever material listing you can get, show report, and you can get this material listing here. You can get this material listed MB300, which are the types of materials which are being used. And lastly, you can also find the concrete also, reinforcement. So total steel, structure steel, total reinforcement steel, total concrete. Again, I find everything in the material listing, and embedded carbon, show report. So carbon level also, you can find out the embedded carbon also by level, uh, kg, CO2e per m square. So you can find it also. So this is also a thing which many new buildings or new projects are required because growing environmental concerns. And obviously building design report. This report is usually large for large buildings. And you need to submit it to the authorities wherever you are there. So another one thing which I complain of this, in this there is no complaint, but in case of large structures, there are many warnings here in Tekla Structural Designer, and then it is difficult to convince the authorities that okay, this is okay. But in general, you have to make sure all these things are passed, and then only the authorities, any governmental authority, vetting, structural vetting authority will pass it. So this design report is very essential. Okay, whether in any software like STAD or RCC, this ETABS, this design report is required. Okay. So hope this was useful and you got to learn something new here. And anything which you want to know about this Tekla Structural Designer software, comment below, and also check out my channel for other videos related to other topics. Okay. Stay blessed. Bye.